Hey everybody, welcome to another exciting installment. As Rob mentioned, we've got a lot of stuff to go through today. The color control for EOS, the color tools are pretty in depth. So I want to roll through some stuff. We'll answer as many questions as we can in the heat of the moment, and then again we'll do some stuff at the end. If we need to stick later, we can stick later. So really quickly over the next couple of hours, what we're going to talk about. We're going to go in depth into all of the color tools that are in EOS, including some workflow ideas, a really deep dive into the spaces and the tools that are available. That particularly includes working with the gel picker and understanding why you get the results you get, and working with the Tint and Spectral tools, and we'll wrap it up by doing color paths. I think some of the important things that we'll hit along the way will be understanding some of the color vocabulary that we use. You can see a few words here: chromaticity, gamut, spectral power distribution, and metamers. Those are all things that are kind of pivotal to how our color system operates. So we'll be doing a couple of sidebars here and there to dig into what those things are. And then, we get a lot of questions about things like, why do my different fixtures not match each other when I try and go to the same color? Or why do my fixtures not match the gel picker, or things like that? There's a lot of science that's behind a lot of this stuff, so I'm going to try and touch on those things. But hopefully, if you've asked these questions before, I hope to bring a little bit of clarity to that when we get the right time. So getting started. When you want to access the color tools, we put all of our color tools in under the color picker tab, right? So tab 27. So you can either open a color picker tab through the tab selection, hold down tab and type 27, and that will open it up. And the default population of a color picker tab is two spaces. We've got the CIE 1931 space that will open up on the left-hand side. And then on the right-hand side, we open up the gel picker tool. We'll discuss more details about these tools in a little bit, but this is the default that we open you with because these are the most commonly used tools in the color system. If you want to configure the color picker tool, there's a lot of different things you can put into it, right? So if you either click the gear or right mouse click on a color picker tab, you get the configuration frame like you do with a lot of other displays. And these are all the options that you have. So you've got a bunch of different tools to go through, and you can customize what's in that tab based on your needs. Really quickly going through some of these just in a 10,000 foot view sense. All of these are color picking spaces. We use them to get to a color manually. So we'll go through some of those in detail as we go through the day. Tint tools is a really good indicator of an abstract adjustment tool. We'll talk about how all of the color tools are in fact abstracted from the fixture that you're controlling, but this is a really good preview of that. Color path is transition tools, right? The ability to decide how live colors fade. And then your spectrum gives you parameter control tools in a more visual way than just maybe your encoders. Again, the color picker tab will allow you to put as much stuff in it as you want. I think one of the things, as you get more comfortable and familiar with these tools, a lot of these tools offer you a really deep dive into detail, right? And so, something like a color path tool, you may not be using if you're hopping in to someone else's show file and busking a new show in 20 minutes. So, as we go to look at what these tools are, kind of consider what things are useful to you for your workflow. Kind of just filling a color tab tool with everything that's possible makes it harder to operate. You can see 6 color spaces here. for day-to-day stuff, I might just want to choose one of those that speaks to how I work. So just be cautious about kind of too much noise on your screen by opening all the different color pickers. One of the ways that we can kind of get to the tools that we need while we're setting up a workflow is we can open multiple color picker tabs. So like many displays on EOS, you can have multiple iterations. And you can see on the right-hand side, in my top frame, I have a color picker that's got the gel picker open. And in my bottom frame, I've got a color picker tab open that has path and tint tools. So that may be a way to get some tools that I need regularly and kind of split them up if I don't like the way that they arrange themselves in the color picker tab. So you can have multiple tabs. Another way that people work is opening multiple color picker tabs in the same frame. So you can now sort of see that my bottom frame, I put my color palette direct selects. Maybe those are useful for what I'm doing. And in my upper area, I have my gel picker on top, but I've got a couple of other color palette tabs in the same space. So my second color palette tab is my Spectral tools, and my third color palette tab is a CIE space and my color path. So, just kind of going back and forth through those, that's a really great way to centralize where my color stuff is going to take place on my system, but allow me access to multiple tools depending on what I encounter in my programming. So that's kind of that. Also, don't forget about snapshots. When you're laying out tabs, configuring them, putting them in different spaces, snapshots are a great way to quickly get back to a known location, and color is no exception, right? So being able to put this in and recall those snapshots to quickly repopulate those color picker tabs is going to speed you up, and that's really what it's all about, right? So I'm going to dive right into our first color space. And I'm going to say that this is going to be a bigger section. We're going to cover a lot of the stuff with the CIE XY space that has to do with sort of all of the color picking spaces. But we'll look at each of them in a little bit more detail, but we'll cover the bulk of stuff in this space. So first, a little bit about CIE. CIE is the International Commission on Illumination. They were founded in 1900. They're an internationally recognized standards body, right? So much like ANSI or some of the national laboratories in different countries, this body can create standards that are adhered to and recognized as scientifically sound around the world. So the idea is that we use a lot of what CIE research and white papers and things like that come up with to inform color tools. So it's an important body. And I liked this quote from their mission statement, basically, which is that they're devoted to the worldwide cooperation and exchange of information on all matters relating to the science and art of light and lighting, color and vision, photobiology, and image technology. So that's a pretty wide array. But when you start getting into color science, you can start to see how all those things are interconnected. So they're a cool organization. And one of the very first big things that they did in 1931 that we still use today is the XY 1931 color space. The big thing about this color space is that it weighs the space for human perception. So it's got kind of a horseshoe shape to it, and that's because this space acknowledges the fact that humans will see more green and more fidelity in green than maybe they do in the reds and oranges. So it takes us and how we perceive color into account. The difficulty was it was a very small sample set. It was not a very diverse sample set. I've heard someone joke that it was a bunch of white men in their mid-20s, like a dozen of them. So the sample set was pretty small. So it's not necessarily as reliable. There's a more modern version of this. But it's still the most commonly displayed space and used space. You'll see this on your energy facts on your light bulbs that you go, and buy at the store. You'll see this not just in our color pickers, but in other spaces. So even though it isn't as scientifically accurate as some other spaces, it is still really, really common. So that's why we use it as default as well. So for EOS, the CIE XY color space, we put a lot of additional stuff on it. And the first thing that you'll see here is your current color selection. So this dot and these crosshairs will move through the space as your fixtures that are selected change colors. That point, the location of those crosshairs is called the chromaticity, stated in XY values in this space. And that describes what that color is, right? So if you have an X and a Y value, you can pinpoint what that color is based on the space. You'll also see that in the background here, we overlaid the horseshoe, right? So you can see the CIE space. And we also have an overlay, which is the Kodak ProPhoto space, which is a widely accepted color gamut. We'll get into gamuts in a little bit. So a lot of computer programs in particular use the Kodak ProPhoto space. So that is there as a reference for you if you're using things like that. You'll also notice there's a dimmer set of crosshairs that permanently are anchored to the color space, and that is the white point for our gel matching. We'll get into gel matching in a little bit and why this is important, but that sits at the color temperature of 3050 degrees Kelvin. So that's what that sort of dimmer crosshair is in the background. Other things that kind of go around the color picker itself, you have a little color preview chip so that you can see sort of an expanded view what your chromaticity is. You have a brightness bar with a push to full button. A little bit of a sidebar, brightness is different in intensity. A good way to think about it is with LED fixtures. If my brightness is at 0, that means that whatever LEDs I have in that color system, red, green, blue, for example, are all at 0. So there's no light coming out of the fixture. So even if my intensity is at full, I'm not going to get any light out. So at the very top of the brightness area, there is a little up button, and that will click the brightness back to full. So if you're turning on a light and you're not getting light out of it, check your brightness settings. Obviously, they're different. Okay. We also have individual control bars. So you can click in the color space, and that will drag your X and Y. You can click along that brightness bar, and it will change your brightness. Or you have bars at the bottom that you can click and drag those, and they will move things. That's particularly useful if you're using this space, for example, when you want to nudge a color just a little bit to the left or to the right. You can do that down on the bar with a little bit more ease. And keep in mind, right now we're displaying color in a flat two-dimensional space, but remember this sidebar, the brightness, right? Color is in fact a 3D space. You can see this in a lot of different applications and tools. Our new phosphor panel on the ETC website has a pretty nifty little video that shows the 3D color space that fixture has. So just keep in mind that there's a lot more dimension to color than just the 2D space you're clicking in, and the way you access that is the brightness bar. We have a few more overlays for the CIE space. If you look, every color picker that we'll talk about from here on out has a little information area, and you can see that overlays information about, at the very top it says what color space this is. This is CIE XE 1931, XY 1931, and then my X and my Y areas with my brightness on the side. So this will just orient you in a color space if you are not sure what tools do what. New in 3.0, if you work in film and TV with cameras, things like that, we have placed in buttons that allow you to overlay the Rec. 709 and Rec 2020 spaces. So these are the gamuts for HDTV and UHDTV, among some other things. So again, just for reference in the color space, with those buttons enabled, will put those spaces over top, and you can see where those are. And then there is a selected fixtures gamut. So anytime we grab a fixture on the command line, we will show a gamut if it has one. So our first big sidebar is going to be into gamut and what gamut is and why we display it. Gamut is sort of, in short, the colors that a fixture can get to. And you can kind of see here, I've got my luster to space shown. So we'll look at that more in a second. But basically, if the profile that you used in patch contains data about the gamut, we're going to display it here, right? We call those fixtures color calibrated, and that means we know very specific things about the parameters of the color system, right? And that gives us a lot more accurate color picking. So if we have a gamut line for a fixture displayed, the color picking that we do, the gel selection that we're going to do, is way more accurate than if one of these gamut lines doesn't show up. Again, this is the gamut line of a source 4 series to luster. And you can sort of see here, we know exactly where the red emitter is in the series 2 luster. We know exactly where the other colors are and where they sit in the color space. So we can get a really accurate picture of the capabilities of that fixture, and when you send it control information, it will more accurately respond. This is, an RGB unit that has gamut data, right? So this fixture, we know exactly where the red, the green, and the blue are, which is important, and we'll talk about that in just a second. But not all fixtures have gamut data. Either the manufacturer hasn't provided them, or it changes, right? It's a really large window. I'm sure you've gotten fixtures from the same manufacturer where the blue is very different fixture to fixture. So if we're provided with really accurate gamut information, we'll use it. If we're not, we'll use a generic gamut based on the fixture's color parameters. And I think it's important to note here that not all color combinations have generic gamuts, right? We have to build generic gamuts custom into the software. So for example, RGB, RGBA, those are very common gamuts. You can still use the color picker. If you're using a generic gamut, it will be less accurate, but it'll still kind of get you in the ballpark of where you're going. You may have experienced where you have a fixture where the color picker doesn't work. And that's because whatever its arrangement of parameters is, the software doesn't see that collection of parameters as a color system, as a gamut that we can put a generic application on. So that is something that as we get requests, as a color space becomes popular, we look at adding those gamuts into the software, but it's a pretty intensive process to add those things into the color system. Another sidebar that you may have seen is fixtures where part of their parameters use a gamut. So if you've got something like an RGB and a cyan, maybe EOS doesn't understand those 4 colors together in a single gamut. And so as you click in the color picker, it will change the RGB, but the cyan will remain untouched. That is something that, again, as gamuts are brought in, we can understand that, but we don't really keep track of every single color combination that's out on the market. So just know that about generic gamuts. Going back to RGB, again, even if we know it's an RGB fixture, which RGB is it, right? By their nature, LEDs in particular are narrow band emitters, right? They emit light in a very narrow set of frequencies. So red is very spiky in the visible spectrum, green, blue, etc. So what we can run into is if an RGB fixture, if we don't know what the gamut of the real fixture is, and we're applying our generic gamut to it, when you go to pick a color in one of the gamuts, it's going to give you a different result in the fixture, right? So this applies to a generic gamut being applied to a fixture that we don't know the gamut of. It applies to two fixtures that maybe have the same parameters but have different gamuts, right? You can see those gamuts are sort of rotated off of each other. That is going to result in different colors, right? So even though you may click in the same space, if you've got two fixtures that are RGB, for example, from two different manufacturers and their gamuts are offset, if the console doesn't know the gamuts for both fixtures, then you're going to get colors that are different, right? That's something that, again, the software is doing the best it can with the information that it has. And so you're going to get some discrepancies if you don't have calibrated fixtures. That's kind of the way that it is right now. So, so this sort of also answers the question, why don't my LED fixtures match the EOS color that's displayed, right? EOS is going to display mixed color not only on the color picker, but we show you in the gel picker, in color palette chips, in magic sheet objects, now in the augmented beam. Why don't those, my LED fixtures, match what's being displayed on my screen? And that's because monitors are RGB sources, and ultimately they have their own gamut, right? So the likelihood that the gamut in your monitor is the same as the gamut and the emitters that are in your fixture is very unlikely. And in fact, manufacturer to manufacturer, monitor to monitor, you may get different gamuts. There are color calibrated monitors for video and TV, which are very high end and very expensive. Those are your best opportunity. But again, the likelihood that those emitters match your fixture is very unlikely. When we get into gamuts with more than RGB, that also starts to affect how this looks, because if you have an RGB fixture, that's great. But if you have an RGBA fixture, your monitor doesn't have amber emitters. So immediately you're losing out on some of the spectral contribution of that fixture on your monitor. So I like to say that all of these color spaces, all of these color picking tools are orientation spaces, right? They're designed to get you oriented. They're designed to get you an idea of what the fixture is generally going to do, but we're never going to be able to display exactly the spectral contribution of the fixture, either because the fixture doesn't match the monitor data or because the monitor doesn't have the output capacities that something like a 7-color fixture does. So I touch a color on my screen and it looks different on stage. Yep, that's gonna be the case. And that has to do with the different color technologies that are being employed in each of these different things. Ultimately, there's no substitute for looking at the fixture in a space and seeing what it's going to do and making adjustments, right? The color picker tools in general will get you to close to where you need to be. You're going to need to refine that stuff when you're in the space. So do we have any questions about the CIE color space or color gamut coming in?
I think the first question that I think we want to hit, that I think will help a lot of people kind of, could you talk about calibrated fixtures a little bit and ETC's approach to calibrated fixtures, just so that's clear for everyone?
Yeah, so we use calibrated to mean two things, which is super helpful, right? Our controls people, EOS and such, we say a fixture is calibrated if we have data for it, right? So if we know, using LEDs again, the exact spectral properties of the red that's being used and the green that's being used and the blue that's being used, then for our EOS language, we consider that color calibrated, right? So that's one way that we use it. And that just means that the color picker and all these color tools are going to be more accurate because we know a lot more information about the fixture. In the fixture side of ETC, we use color calibrated to mean something different. When we manufacture our fixtures, when they're built, there are still tolerances between the same color LED. So one blue LED from one batch that we buy may have different spectral properties than another blue that we buy. And we try and keep that as tight as possible, but there's still variances. So when we build a fixture, we build the fixture with all of the stuff that it's going to have on board. We power it up and we put it in a machine. And basically what that machine does is it reads all of the spectral information that that fixture actually has on board. Not what it's supposed to be, not what it should be, but what is actually physically in the fixture. That machine then records that information back onto the board that those emitters are soldered to. And what that gives is the fixture software the ability to go to what's called a golden fixture. So it says, oh, in this fixture, my blue is a little bit brighter than the normal fixture, than the golden fixture. So I'm going to reduce the output of my blue. My amber is a little dim. So I'm going to reduce some of the other colors to compensate for that. My green is shifted a little more towards cyan. I'm going to compensate for that. So the idea of a calibrated mode in a fixture is fixture to fixture consistency, so that when I turn on 15 source 4 luster 2s, they all go to the same color, regardless of maybe when they were built or what batch was there. There used to be a divide in our fixtures where either the fixture was in calibrated mode, which means you just sent it some really basic data like hue saturation or RGB, and it calculated the color that it was supposed to get to based on the math it had stored on board. The console had no control over that. That was tough because you couldn't ever override that math if you didn't like it. So for a long time, we recommended direct mode, which means that you have direct control of the fixtures, emitter by emitter. There's no math in the fixture, but that means fixture to fixture to fixture, there may be some discrepancies. The fixture team in February, I believe, released a new firmware version for the Luster 2 series fixtures, which is called direct calibrated mode. This has been the unicorn that our engineers have been chasing for a really long time, and it basically gives you all the advantages of direct control and all the advantages of a calibrated space. So it's really smart. I would recommend, obviously, don't upgrade your firmware of your fixtures when you are in the middle of a production, but as we all get back to work, we'll do some maintenance on our gear, hopefully. It might be worth taking a fixture or two from your inventory, putting them in the new firmware and seeing how they do. So Jason did some testing in our New York office with some pretty good results when this first came out. So we're interested to see what you think as well. So long answer to a short question.
And great. Nick, just a quick clarification on that. Yeah. So this has replaced the previous direct mode. It's not a, so you won't see an extra mode. It's the new direct mode.
Yeah, good call, Rob. Thanks. Yeah, it does do that. So when you upgrade to the new firmware, if you put your fixture in direct mode, it's using direct calibrated mode. There's not a direct mode and a direct calibrated mode in this area. Cool.
Next question. Christina asks, Roscoe released the Mixbook LED as an app and handheld light. Will the color picture be able to access the data or have it programmed into the software at some point?
That's a very new product, and we're watching it. You know, we partner with Roscoe on lots of stuff, so I don't have any specific information or timeline, but we're aware of that product, and we're chatting with the folks at Roscoe. So maybe.
Next question. Can you superimpose gamuts on top of each other like that in the software so you can compare it?
You can't. That's based on your channel selection is when those gamuts will show up. And if you have multiple gamuts selected, we show you the cumulative space of all those fixtures, but it doesn't do individual stacking on top of it.
Okay, and then I think this will probably be our last question. Michael asks, I build a custom profile by copying an existing fixture. An update is released with a new gamut. If I update, does it take the new gamut? Will the update window tell me that there is new calibration data?
Yeah, so it will take the new gamut data if you update it because it's replacing your edit. So all that information will be there. And there are notes when you do profile updates in patch. So it should give you some information if that information has been updated. Cool.
Great. Yeah, I think we should move on.
Okay, very good. Cool. So really quickly, let's go through the other CIE space. U prime, V prime, also called LOVE, LEV. This is an updated version of the 1931 space. Like we said, the 1931 space was a smaller sample set. There's a lot of improved science between 1931 and 1976. So if you want to use this space, it is available to you as well. And it's just an updated version of the 31. You can see that there are a lot of the same tools as the 1931 space. We have the same chromaticity and the horseshoe for that space that are here. We indicate the Kodak Pro Photo space and our white point for gel matching. We give you adjustment tools for your brightness for your color chip, and then your control bars on the bottom. And then we also give you the information and then the Rec 709 and 2020 spaces. So all this stuff exists the same. Again, the space is just a little bit different. But this is a good time to mention, I think, that all of these spaces are interconnected, right? If you do an experiment where you open a color picker tab and you open all 6 color spaces, grab a channel and start clicking around, you'll notice that all those spaces are tied together. We'll talk about it in a little bit when we talk about absolute color data and the way that the EOS system actually thinks and translates. But you're not getting an advantage in one space or another. You're not able to control stuff in one space and have a different control in another. They're just different presentations of tools. So keep that in mind. Whatever space you're comfortable with, you're going to be getting access to the same color information. It's just laid out a bit differently. So let's talk about one of the other color spaces, which is the wheel. This is really common in a lot of software, right? Photo editing software, video software, other control systems. This was the default color picker of EOS before we did all of this color work a couple years ago. The hue, saturation, brightness wheel, unlike the CIE spaces, gives equal weight to all colors. So regardless of human perception, you can see that all colors are equally represented around the outside of the dial. So it's a little bit more predictable when you're trying to move through the different hues of color, right? A reminder that hue is a special type of parameter. It is a circular parameter. So the way that we move crosshairs in a hue saturation space is not by XY. We move it by rotation of hue. And hue generally in most color spaces, including ours, the 0 is at red. And it rotates around to get you through the various color spaces. So that decides what hue we're in, and then we use saturation, which is linear from the center out saturation. So all the way saturate to the hue down to no saturation, which is in an LED system, all colors on. Remember that you have a brightness bar still. So that will allow you to select things that aren't full brightness. So there you go. There's a lot of the same tools. Again, the control bars, the brightness, the color chip. There's no Kodak ProPhoto space laid over on this because ProPhoto is based in CIE, and the same with 709 and 720, 220. So those spaces don't really apply here because they weren't designed on top of this space. So just be aware that those things aren't available in these spaces. I'm going to take you quickly through the color space planes. There's a series of planes that are useful spaces if this is how you want to work. This is the hue, saturation, brightness plane. So it's similar to the wheel in what it displays, but it provides a little bit more space and accuracy to work in that it's expanded larger than the wheel. And in plane spaces, so your saturation and brightness will by default be on the plane, and you can see in the bottom that the title of hue is lit up, and so my hue is on my vertical bar. So that allows me to control which hue I'm talking to and deal with saturation and brightness on my field. I can really change that very quickly. If I click on any of these plane spaces on the title on the sidebar, it's going to change what's on my vertical axis. So for example, if I click saturation, it's going to put my hue and my brightness on my plane and my saturation vertically. So you can see that with red from no saturation to full saturation. Similarly, if I put brightness on my bar, this gives me something that's very similar, again, to like a Photoshop or a paint tool system, where my hue and my saturation are on my plane and my brightness is on my vertical bar. So if you're using this plane, whichever way you want to work, we give you access to that. For your RGB space, your RGB plane, it's similar, right? We've got the vertical axis. Because RGB LEDs home to full, if you want to kind of explore the effects of this, you want to take those parameters down to 0. And when they're at 0, you can see red on the sidebar, right? It's from full intensity down to no intensity, right? So the brightness of the red emitter is on your sidebar, and green and blue are on your field. Similarly, if green is on the sidebar, and similarly if blue is on the sidebar, right? So just however you want to orient that space. RGB is very similar to CMY. I think the big thing, and I'll click back and forth here, is that they're sort of opposites of each other, right? RGB is your additive color, CMY is your subtractive. So they're similar in space, but you get different tools for them. So if cyan is on the sidebar, that's what that guy looks like. If magenta is on the sidebar, and if yellow is on the sidebar, right? So again, pick a space that is what you prefer, and know that you don't have to work in all the color pickers. You can just work in a single color picker or 2 color pickers, and that will help you. Again, I recommend you taking and opening these spaces just to play and dragging them around. You'll see that all the color spaces will change together because they are abstracted, meaning the math is done before we worry about what type of fixture we're controlling, right? So all these color spaces will get you similar results regardless of what space you're using on a particular fixture. So for that, are there any general questions about the color spaces before we go into some of the control tools?
We have 2 questions that just came in. Mark asks, hue will only move clockwise in the HSB wheel, correct, when dealing with a color path?
Yes, right now we don't have a way to override which direction a fade path takes for the fade. And that really has to do with the fact that there's not hue is 0 to 360, and there's no negative, right? So we can't do that. So that's been on the list for a while, but not right now.
And Neil asks, is there a way to set the brightness bar to a percentage so that say I use a gel picker to pick a saturate blue, I can set the brightness to match the transmission of my gel?
Yes, you can set the brightness, but the transmission of your gel is going to be different than the output of an additive fixture, right? So again, I think that's something that I would eyeball. That would be something that I would have to do in the space. Because of the different sources, you're never going to have a percentage transmission of your gel equal the output of a bunch of LEDs adding light together. That's just not how the color spaces work. We'll talk a little bit about what gel is in a second when we talk about the gel picker, just as a reminder, but those are sort of apples to oranges. That's not a way that you can work. Cool.
That's it for right now.
Cool, excellent. So let's get into the gel picker. And in my mind, it's not the gel picker. It's the gel estimator. And this is really kind of based on what we were talking about with how much information does the software have about the fixture and other things that are there. So the gel estimator tries to approximate the color that is produced by a gel in front of a lamp. And I want to take a sidebar because we really need to ask, what are we trying to do, right? What are the expectations here? I've got an LED fixture with additive color mixing, or I've got an arc source with subtractive color mixing. And what am I expecting when I have when I use the gel picker with those sources? And this is Sam's favorite slide in the whole world. What we're generally asking the console to do is take my LED fixture, apply a gel picker pick that I do, and it's going to look exactly the same as an incandescent with a gel in front of it. And that's just not ever going to be reality. So let's first examine a little bit about what gel is and why gel changes the color of an incandescent source. Gels are also known as filters, and that's because they cut out certain wavelengths from passing through. So you can see these are the filtering characteristics of Roscoe Lux 39, right? This has, it limits more of the cyan and green and yellow than it limits the indigo, the blues into cyan, and the yellows into ambers into reds, right? It allows more of those to pass, and it stops more of the greens. So this is just filtering whatever light is provided to it. So there's a great article that's by Wendy Lutke, who worked for Roscoe for a lot of years as their color product manager. She now works for ETC as our color product manager. But this was an article that she wrote on Roscoe's blog, how to properly choose a color filter. I think it did a really great, simple job of explaining how this stuff works. And so in this article, she compared a cool white LED source and an incandescent source, so two perceived white sources. But if you'll look at the spectral content of what is the source, you can see that the incandescent is putting out energy at every wavelength in the visible spectrum, a lot more in the red than it is down into the blue, right? So that's an incandescent source. That's why an incandescent feels warm. By the way, daylight puts out roughly the same amount of power at every wavelength, which is why it's sort of considered a perfect light source. If you look at the cool white LED, you can see that it doesn't have all the same spectrum at each wavelength. It's not emitting the same amount of energy. So what we call this whole thing of a source is the spectral power distribution, or the SPD. This is what a light emits at each frequency. And so when you're talking about a gel, you're applying a filter to the source. So for something like a incandescent, where we're allowing a lot of the blues and indigos to pass, we're filtering out a lot of the greens and yellows, and we're allowing a lot of the reds and into deep reds to pass. That's fine on an incandescent source because there's a lot of stuff there. But if you look at the cool white LED, that particular source has a lot of spectrum being blocked, and there's less spectrum in the places where it's being allowed to pass, certainly in the reds, right? It's letting a lot of blue pass. And so what you get is the same gel looking very, very different because the source is different, right? So what we have to do when we're thinking about a gel is understand what source and then apply the filter. You can't just look at a gel and know what color it's going to be in front of a particular source. You have to hold it up or use it in front of a source that has a similar spectral power distribution as the source you intend to use in real space. So what does EOS do in this case? Well, we're trying to match an LED fixture to a gel. First, we got to choose a source, right? We have to assume what source we're going to pass through a gel to do it. So when we started this color work many, many moons ago, the HPL long life 575 watt lamps were about 80% of HPL sales. That is a pretty significant chunk of what people were buying. And it happens to have a color temperature of 3050 Kelvin. So we're using the spectral power distribution of an HPL 575 watt long life lamp as our source to inform our gel picking, right? So now that we have a source, we can also load in all of the filter characteristics. So we'll look at the gel picker in a second, but if you've been in there before, you'll notice that we have all of the different manufacturers' libraries, and we have all of those filtering characteristics built in. And what we're doing in the software is we're taking our source and we're pushing it through the filter and getting the resultant spectral power distribution, which we call the absolute color or the XYZ color, right? So we're taking sort of our source, we're putting it through filters that you select, and we're getting the XYZ color. And then once we have an absolute color or an XYZ color, then we worry about translating it to the type of fixture in the color space for output. So when I say that all these color spaces are abstracted from whatever fixture you're controlling, all of the tools that we talk about, even if we're dealing with RGB or even if we're dealing with CMY, all of those spaces are actually controlling settings that are modifying the XYZ color space. What makes that really powerful is that we can very easily use things like CMY controls on an RGB fixture, and it understands how to reduce the cyan even though I may not have a cyan parameter. So I think that's one of the sort of secret sauce things that makes EOS color tools incredibly powerful, is we're always going to this centralized color system and then distributing it. And you know, a lot of you are lighting people, and I know lighting people are a little nerdy. So Chris Mizrak, one of our developers who wrote a lot of this code, provided an actual snippet of some EOS code, right? This is our conversion hierarchy where we take our source into our XYZ space, and then we convert it to all different sorts of spaces, right? So this is something that we are constantly improving and evolving, and so yeah, that's actually how the code functions and the code is written. So what are the results of this? Remember our fixture gamut? The fixture gamut, when we go to translate from absolute XYZ color space down to actual output, when we're trying to talk to a fixture is only going to be able to get to a gel match that's within its gamut. So what if I really want to match a gel on my RGB fixture that's out here? Too bad. the physics of that fixture don't allow you to get to that color. So when you're picking, when you're using the gel picker to pick things, keep in mind that the fixture may not be capable of getting to that space. What's really nice about an incandescent source is it's outputting light at everything in the visible spectrum that the human eyes can perceive. And so that whole horseshoe space of the CIE color spectrum, gel can get to, because gel has the ability to filter or pass wavelengths that get it anywhere in that spectrum. Additive color fixtures in particular may not have the ability to provide a full source. And when you start talking about subtractive color systems with arc sources and things like that, or white light LED sources, you also have to consider the gamut, because the white source may not be full spectrum in the same way that an incandescent or daylight is. So do some research understanding the source of your fixture, do some research understanding the gamut, particularly for additive fixtures, and that will give you a really deep understanding of how the limitations of your rig exist in physics, and hopefully will have you not be as frustrated when you're trying to get certain fixtures that are one gamut to go to the same color as perhaps another gamut, or a gel that's outside of the gamut altogether. You know, kind of moving over to our fixture side, one of the reasons that the folks who started Celador, which ETC eventually acquired and has moved into our X7 and X8 color systems, is that fixtures with larger gamuts can access more colors, right? You know, Celador wasn't playing the numbers game of, well, we're just going to do is, you know, you have 7, we're going to do 8, we're going to do 9. It's all about expanding the gamut so that you can get to more of those colors in your space. And so something like a 7 color system is always going to be inherently better at getting to more colors than something like a 3 or a 4 color system. And sort of put another way, right? If you look at the spectral power distribution, and this is taken from our Spectral tool, which we'll talk about in a little bit, the more colors you use in your attempt to replicate a complicated SPD, the more accurate your results will be. So at the very top, you can see my R72 in absolute space, right, in XYZ space. That is my filter compounded with a source, our 3050 Kelvin source. If I'm using RGB to try and get to R72, I don't have as many variations. I can't dial in as much. Similar with an RGBA, I get closer with my amber. I can add a bit more spectrum. And then you look at something like the new phosphor 8-color system, and if you look at sort of the cumulative wavelengths in that white line below the dotted line, you can see that you can start to get a lot closer. That's physics, that's science. That's why companies like ETC are putting more narrowband emitters into fixtures. Do we have any questions before we hop back into the gel picker about gel math and that stuff?
Yeah, I think there's one question that I would like to touch on. Oh, is it gone? 1 second. It might be gone. There's one question that I wanted to touch on. Here it is. Jason asks, is it true to say that fixtures with a higher CRI will accurately render the gel color?
No, it's not true to say necessarily. It is possible. I know Wendy Letke's in here as well. I really encourage you to look at something called TM30, which is something that Wendy has had a big hand in bringing to fruition. In short, CRI is very easy to manipulate, specifically with LED fixtures nowadays, because you have narrow band emitters that only uses a maximum of 15 color chips. There's a new standard in architectural lighting in particular called TM30, and it uses 99 color chips to assess color fidelity. So maybe a higher CRI would render gels better, but if you're in a red area and that fixture has a really low CRI rating in the red, then maybe it won't render. So So I would explore TM30 and see how that can get you more accurate information about your sources.
Next question I think is important to touch on. Jim asks, if you have two different gamut instruments and you use the gel picker color to pick a color within their gamut, will it be the same color for both instruments?
The answer is kind of, right? And we'll look at this in just a little bit. But basically, it's going to take those fixtures to the same chromaticity, and it will use a metamer when we talk about those that is based on your selection. So if I have, for example, two calibrated fixture profiles for an RGB and an RGBA, I have them both selected, and I click on a space in the color picker. They're not going to look exactly the same because one of those fixtures doesn't have amber in it, right? So so that is something that is you're going to have to go in and adjust manually. If you have two fixtures with different gamuts that are the same color system, so I have an RGBA and a different RGBA, and they're both color calibrated, yes, they should get really, really, really close. So the different gamuts are giving enough information to say, again, go to this pure XYZ color space, go to this chromaticity, and then translate to the fixture for output. So same color system in two different fixture manufacturers that are calibrated should be really, really close. Different color systems, it's apples and oranges.
Great.
Cool.
I think let's move on to get through
Okay.
content, and then we'll hold the rest of the questions.
Cool. Very good. Great. So let's go back to our gel picker. We kind of skated by it for a sidebar. Looking back at the tools, we've got a bunch of things. Your vertical ribbon that's going to be on the left-hand side of your gel picker has a bunch of different libraries. The standard color library gets you various color temperatures, and it gets you some get started colors. So a lot of people ask me when I'm out and about, when are we going to get global color palettes? This is kind of it, right? Based on the information that you know about how a fixture can get to a certain place, this is your get started. I just need to busk. I just need reds and oranges and blues and greens, right? You don't have to take all your fixtures and record color palettes for all of those. This will get there. Is every blue and every fixture going to be exactly the same? No. Are we going to do better with calibrated fixtures? Absolutely. Are different color systems going to result differently? Of course. But this is exactly the same as if you were to use a quick picking color system on a lot of other consoles. So that's in your standard colors library. And I like to have that up, particularly for things like busking. At the top of your ribbon is your show library. And this is going to include things that have to do with your show file. So I like to kind of call this the palette of my show. This is going to show you any gels that are stored in the gel field of patch or that are included in a scroller load. So those are accessible to you. It also includes any color wheel chips. And with no channels selected, you'll notice that unlike the other gels, my background is grayed out. And just my titles are lit up with the color. When I select a channel or multiple channels, it's going to show me the colors that are relevant to that channel selection, right? Just like we do with direct selects and other things. So this is, again, a pretty useful place to be for just a general overall view of what sort of things are happening in your show file. Sort of back to the main area, we have a bunch of different gel libraries, some that are common in the US and Europe, some that are common in Asian markets, and you can select any one of these. And again, we're going to give you all of the gels that we have loaded into the library. We try and keep up with this stuff as gel manufacturers bring new stuff in. We try and load in that filter characteristics data into our color system. Sometimes it takes us a couple versions, but we do the best we can to keep up. When you are trying to access these things, you'll notice that all of these libraries have a number in front of them, right? So Roscoe Lux is 5, Lee is 3, Apollo is 1. They were just numbered in alphabetical order. But this allows you to access these libraries from the command line. So if I want to get Lux 26 onto a fixture, I can say one color /26 enter, and because I have the library number, I can then access the individual colors in that library. So this is a really good shortcut without having to have the color picker open. We also allow you some sort tools. So if I'm in a library and I have sort by hue enabled, as you can see, that puts those in hue order, not in numerical order, which is nice. We also have a sort similar colors. So wherever I am currently in the color picker, this is going to show me a collection of colors that are nearby. I really like to use this to go library to library. So if I have a fixture selected and it's in the Roscoe library and I need to know what a Lee equivalent is, I can hop over to Lee with this similar selected, and it's going to show me similar colors in the Lee library. So that's a pretty useful tool. This is a tool that just changes the display of your gels, right? So you can see that that icon has a light beam, and this is showing the swatches with the XYZ color space, right? So as they look with a 3050 degree Kelvin source behind them, right? So my R0, which is clear, is a little bit warmer. So this is what you would expect to the best that an RGB monitor can replicate. This is what you would maybe expect a color to look like going through an incandescent source. If you're much more familiar just looking at the swatch book, or you have a cooler source that you're dealing with, clicking on that button will get you an icon that looks like a swatch book, and that's going to show you just the gel characteristics on a white background, right? So this is what that gel may look like if you're looking at it up against paper. So it just changes what these things look like. It doesn't change how it controls the lights. It doesn't make any changes to our source color temperature for XYZ color modeling. This is just a display thing. So use what you want based on what you're comfortable accessing stuff. And the last button that's a part of the gel picker is your metameric selection, or which metamer you're going to apply. And let's hop into yet another sidebar. I think that'll be the name of my sitcom if I ever start one. It'll just be yet another sidebar. It'll be all sidebars. What are metamers? Metamers are a phenomenon, particularly with additive color systems, LEDs, in entertainment lighting, that we call a color recipe, right? And it's basically the ability to have the same chromaticity, the same XYZ component, with multiple ways to get to that same location. Again, remembering that color is actually a 3D space. In a 3-color system, there's actually only one way to get to a point, right? And that's geometry, right? That's basics of a plane. If you have 3 points on a plane, if you were to like draw little lines of distance between each of those points, you can't describe the same location with multiple values. It's always only going to be one set of values that describes that location. And similarly with color, the values, if you change any of those values, you're actually shifting the chromaticity in that color space. But as soon as you add a 4th color, you have the possibility to get to the same point with multiple recipes. So for example, this particular point in an RGB system, I could get to with different color combinations, right? And the thing is that because LEDs are very notched, this is going to maybe look the same on a perfectly white reflective wall, and that's really what the CIE color space is dealing with. As soon as you put these different metamers on complex reflective surfaces like skin, like fabric, perhaps with different dye layers, scenic paint with many layers. This is where the same chromaticity can start to look different, right? So metamers are really important in design, because if we have access to multiple metamers, we can actually subtly shift what we're talking about. Tom Littrell from ETC does a great discussion that I think is on our website now, which is 50 Shades of R80. And that discusses a lot of this metamer stuff in detail. So I recommend going to look at that for a deep dive. On the control side of it, we want to give you access to pick multiple metamers. So what's kind of cool about a color system is the more points you add in the color space, the more possibility you have of having multiple metamers for the same chromaticity. So in a 7-color system, and I'm going to make this up now, maybe Roscoe 80 has 8 metamers, right, that are at the exact same chromaticity point, but have different color recipes to get there. So when you look at a color like R33, R33, you can see here that even with a 7-color system, I have multiple combinations that can get to the same place. And if you look in particular in the center of the spectrum, there's different combinations of emitters that are actually holding that exact same chromaticity. On a white wall, they'll all look the same. On a person, they won't. So that's important to know. So if you can get to all these places and you click in the color system or a gel, which is just a chromaticity, which one does Eos choose? And that's where this brightness button really comes into play. So you can click on that button and it will toggle through 3 different states. And the 3 different states are brightest, spectral, or hybrid. And whatever one is selected when you click the brightness, when you click the gel, is which metamer it's going to use for that. For brightest, it's going to pick the metamer that has the brightest output, right? And so that will push more light to the stage. But oftentimes, that doesn't look necessarily as true as a gel in front of an incandescent source would. So spectral is the opposite of that. It tries to match the XYZ color of that gel with your emitters, right? But oftentimes, because of how notchy those gels are and the properties of additive color systems, you oftentimes lose a great amount of your brightness in that. I know there have been some improvements in the color system over the years to try and lessen that, but it is something that we do have to deal with just by the physical nature of LED systems. Hybrid is somewhere in the middle, right? It picks a metamer that gets you closer to the spectral match than maybe a brightest would, but it also doesn't quite dip you all the way into a full spectral match. So clicking through these is something worth doing. And when you're using the command line, which one do we do? We pick the lowest number tab and whatever that one is set to. So what is your tab 27 set to if you're using the command line? That is which of these metamers we will be using. We also have some display conventions in the channel. We have to squint a little bit here, but you'll see that if we're doing brightest, we show you that channel 1 is using a gel match, R72. In spectral, itty bitty, you can see there's a little period in front of the gel match. And that's us indicating to you that we're using the spectral metamer of that gel match. And then hybrid, it's 2 dots, right, a colon, and that indicates that we're using the hybrid. And this is just whatever you used to get there, right? Once this is stored, it doesn't matter if you change that button. It's not a mode. It is just the next time I hit a color selection, which of these 3 metamers is it going to apply? So if you've stored a gel match in a queue or a color palette, that will be able to be there until you go back and change it some other way. So don't worry about changing that tool. It's not global. It's just what am I going to do with this tool right now? Any quick questions about the science of Metamers or the gel picker?
Yeah, one question came in. John is asking, what is Roscoe Other?
Roscoe Other has a bunch of other Roscoe color filter products in it. I think it's some of their smaller libraries. I don't remember all the brand names, but it's just another library collection of Roscoe-made stuff.
And I think this is actually the very last thing you touched on, but I think it's worth noting. How does the brightest spectral hybrid switcher work? Do you change it and then reselect the gel to update the chosen metamer?
Yeah, that's exactly it. So if you don't like the brightest, when you click on R72, click it over to Spectral and click on R72 again, and it will apply that to the fixture. Click it over to hybrid and redo it. If you're using that a lot, or you know there's gels that you're going to be using often, maybe color palletize those things ahead of time so that you have a couple of color palettes you can just pop between. It's an option. We're just storing the parameter values at that point, so it doesn't matter.
Next question. We did that. Sorry.
I'm just seeing one that I want to address really quick.
Yeah.
Peter asks, I tried it and it doesn't seem to change the RGB value. It's not going to change anything in RGB. Metamers only work in 4 color or greater systems. Metamers do not exist in 3 color systems. And those are color systems. RGB W, the W doesn't add any additional gamut. It only adds brightness, right? So if you're dealing with an RGB W, you're not going to have access to Metamers. You have to have an additional color in order to expand your gamut.
Ben asks, just to clarify, the brightness setting will only affect the metamer for fixtures. Oh, you just said this, more than 3 color systems, right?
Yeah, correct.
Andrew wants clarification. Brightness settings will be recorded into palettes. Is that correct?
Yes, because again, all of the tools that we're using to get the XYZ color eventually gets translated into the native color space, which is the collection of parameters, right? So what we're actually storing is the collection of parameters. All of these tools are just fancy ways to get those parameters set in a way that you want it.
Great. I think we can move on.
Cool. We're actually clipping along well, so I think we'll be able to get through the next couple sections and then answer a lot of questions. So the next tool set that we want to talk about is the spectrum controller, which is one of my favorite because it sort of displays light how I think about it, which is in the visible spectrum and sort of power distribution or power potency for each emitter. So in the spectral control, you actually get access to parameter direct controls. It's the only space in the color picking tools where you are directly controlling parameters, right? As I've said, everywhere else, we're doing all these neat things to control the XYZ color and then translating that down to each individual fixture type for what it needs. Here, you're controlling individual parameters. So really quickly up at the top, there's just a little ruler for your wavelengths of the visible spectrum. Again, this will be more accurate based on what information we have of the fixture, and it is for sort of illustrative and orientation purposes more than it is scientific purposes. So just be aware of that. These are your control handles. So the dots that are at the peak of each of these things are actually adjusting that parameter. So if I take my red and I move it down, I am doing exactly the same thing as if I were to take red on my encoder and roll it down, right? So these are direct parameter controls, which is great because then you can adjust individual parameters and with some of the other tools still deal with some of the XYZ color tools. Below, you'll see that we label what parameters what so that you can see what you're controlling. And we give you individual parameter spectral power distributions. So you can see the deep red and the red in this phosphor fixture and the indigo are pretty narrow. If you look at amber, it's a very wide hump of spectral power that it outputs. Again, lime takes up a large footprint. Green has a bit of a wider footprint. So that just gives you an idea of where you're contributing spectrum, because that's information that the color system needs to know. So again, the more accurate information we have about this from the manufacturer, the better this will be. We also show you the cumulative spectral power distribution. So this kind of white line, the gray line, gives you information about what all of the emitters are doing. So that's a good thing when you're trying to match a gel, for example. There's another tool which is newer to the color system. It wasn't there from the original, and I should have zoomed in on this for my presentation. But in the bottom corner, there's a little thing called max brightness. And what it does is, as you're mixing colors, it knows the potential of how bright each of those emitters can get. And if it sees that the color that you've mixed can be brighter, the button highlights, it lights up, and what you can do is you can click on it and it will keep the exact same color mixed and just push it to its full brightness. So this is really, really useful when we've like, oh, take the blue down a bit, now take the green down a bit, now take the amber down a bit. And we're trying to get that perfect color by shaving stuff off. If the fixture has the ability to then re-add that to be a brighter color, we want to do that, and then we want to control the brightness of the fixture with our intensity, the output of the fixture, right? The brightness will preserve the color mix and maximize it. So that's a really, really useful feature that's only available in the Spectrum Control Center. We also have hold color point, and I like hold color point. Rob mentioned this as a great phrase, which I'm stealing, which is that hold color point is really sort of a customized metamer, right? When hold color point is enabled, it locks the chromaticity of that fixture. So similar to our 3 metamers that we can pick in the gel picker, as you drag these individual parameters up and down, you'll see the other parameters auto adjust to hold that chromaticity. So this is a really good way to kind of do customized metamers that may not be one of the 3 that you like. A really good example of this is I've got a color that I like. It's a moonlit night color, but the red in the fabric of the dress is popping too much. I can come in, click hold my color point, and then as I adjust those colors, the other colors will compensate to keep the feel and the tone of that color the same, but maybe adjust the spectral content. Again, this only works on color systems that are 4 and above, and color calibrated fixtures are going to give us more accurate results. But this is a really, really great thing to adjust those parameters. And again, all it's doing is adjusting those parameters for you so you don't have to think about it. Once you store this into a color palette or whatever, we're just storing the individual parameter levels. I want to go through our tint control tools really quick. This is another toolbar that you can assign. The tint tools give you abstracted color control like we've been talking about. Now that you understand that we're actually modifying the XYZ space and then translating it, I think you'll understand the power and why these tools are pretty useful. I have called these for forever the designer tools because this is how a designer speaks to me as a programmer. I want it a little bit warmer. I want it a little bit cooler. I want it a little bit brighter or less bright. I'm dealing with a CMY fixture and they're like, oh, take the green down. It's too green. Well, I don't have a green parameter. But here I can adjust the green and it understands how to remove green without me having to think about individual parameter controls. Wendy always calls these the uppy downy buttons, which I love. Because they let you go uppy and downy with all of the different things that you have. So I recommend that you play with these. These are really useful to have in your arsenal. We give you tools to adjust color temperature. So I like my mix, but I generally want to make it warmer or cooler and keep the same composition. I can adjust my saturation from here. And this is great if you have a bunch of fixtures selected. I've got different color spaces. I don't want to think about how I adjust my RGB versus my RGBA versus my A color. Just reduce the saturation for all of these. Similarly with brightness. And again, the scene is too green. It doesn't matter if I have 5 different color systems selected. I can pull the green out of them, and that is going to do what it needs to do for each individual color system. So it's really, really smart and beneficial to give over a little bit of trust to the console that it's going to manage those color systems for you appropriately. And similarly, CMY, right? Again, these are just things that we can use. We don't have to be dealing with a CMY fixture to use those adjustment tools, which I think is really, really useful. Any quick colors about the spectral or tint tools? We're going to go into color path, which is the last section, and then we'll probably have plenty of time for questions. What do you think, Sam?
I have a couple tint questions that maybe we just hint those now. The first one is, Andrew asks, how sensitive are the tint control buttons?
The right amount of sensitive.
Yeah, I guess we know. I wasn't sure if there was a number for that or if that was just. I know designers hate numbers.
I know that there's a number associated with it. I don't know what it is off the top of my head. You can press and hold them. I know people sometimes think that they don't jump far enough. If you press and hold saturation, for example, it allows you to do that. I know another trick that Rob Crane uses pretty regularly is there's a setting in EOS settings, which is enable hue saturation control, which will actually put a hue and saturation virtual parameter on every fixture with a color mixing space. Before we did these color tools, it's how we used to control color with all hue saturation. It turns out, as you saw with the wheel, it's generally not a great way to control color. But what it allows you to do is build hue and saturation macros. So for example, you can have a saturation macro that adds or subtracts 1%, 5%, whatever. So that's useful. The tint tools aren't macroable. It's something that's been requested for a while and just hasn't been gotten to. But that's a way to kind of get around it, is to enable the hue saturation tools, which don't really have anything to do with its color system, but give you parameter control of hue saturation with the color mixing system.
And then we have a question from earlier that we would like to hit. Doug asks, are there any particular disadvantages to using the Create Virtual HSB option in the EOS system settings? Why is the option disabled by default?
Yeah, so once we started doing all the research that led to these color tools and a lot of other fixture-based tools and stuff, again, Wendy works in our advanced research group. They do a lot of research on color, among other things. We kind of came to the conclusion that HSB is a really terrible way to control stage lights. It's really great for graphics, again, in places where you're giving equal weight to red, green, and blue. HSB is great. We care about what humans perceive it as. We care about complex spectral sources like gel, and HSB just really wasn't a great space. So when we introduced HSB, or when we introduced the color tools, we wanted to take HSB as a control mechanism at the parameter level completely out, but that would break previous show files, which is like #1 tenement in our development rules is don't break show files to the best of our abilities. So we gave you an option to turn it on. Again, we preserve it if it's a show file that you're opening that used HSB. By default, we have it off because it's not a great way to control color. However, things like doing these macros, like Rob suggested many moons ago, are very useful. There's a couple of color effects, hue saturation default effects, which run on the hue saturation parameter, not on the mix. So if you want to utilize those, you need to enable HSB. So it's kind of a legacy tool. It isn't super great. There's still a couple of reasons why you might want to use it, which is why we allow you to enable it. But by default, when you start a brand new show file from scratch, we have it turned off so as not to confuse the issue, basically. We allow you to turn it back on if that's something that you like. Good question.
Next question.
Yeah.
Peter asks, does the RGB CMY uppy downy buttons do the same thing as the CMY and RGB sliders in the CMY RGB pickers? Or are there other smarts at work to give you the benefit of just hopping to that picker style?
No, that's exactly right. So we're just adjusting, again, because all of these color spaces are abstracted from, the math is abstracted from the physical fixture. You can absolutely use your CMY plane color picker and adjust the cyan on the side. The tint tools give you just sort of a centralized collection of all that, but it's doing the same functionality as the RGB and the CMY tools that are in those plane pickers. So I think that's kind of the advantage there. Just for clarification, adjusting those CMY things are not adjusting your cyan, magenta, yellow parameters, right? Same with RGB. So in a color system where I have a red, green, blue LED fixture and I reduce the red, it may also adjust some of the green and the blue because it's moving away from the red coordinates of the color space. It's not directly controlling the red parameter. And you'll particularly see that when you do something like an RGBA fixture, where as you move away from red, your amber is definitely going to adjust as well. So keep in mind that everywhere else in any of the color picking and adjustment tools, the only place you're actually controlling the parameter is in the spectrum tools with those dots that you drag up and down. Every other place you're adjusting the math, you're adjusting the abstract space. So I've gotten that question before where it's like, I'm hitting red down and red's not going down. It is not a parameter tool. It is an XYZ color space modification tool. So just keep that in mind.
Great, and I think that actually answered our last question, which was, are controls affected by the selected color matching algorithm, or do they take more direct control, like spectrum display?
Great, good to know.
Oh, cool. All right, then let's move on.
Let's soldier on to fade path. So this is sort of the last piece of the color tools, and it's a really powerful thing in that, you know, EOS gives you a lot of refinement tools, right? It gives you the ability to really go in and nitpick how, in particular, transitions happen, right? We care very deeply about how we go from one static state to another static state, and the color fade path is no exception to those tools. Basically, without a defined color path, which is the default, right? You record color A in Q1, you record color B in Q2, and with that light being on, we're just going to fade the parameters from their stored point in point A to their stored point in QB. So some parameters may be traveling a lot and very quickly. Some parameters may be traveling a short distance. Certain parameters may be traveling in opposite directions depending on where they're headed. But we call that the native color space or a native fade. And that just means that just like a dimmer, we're just saying fade from point A to point B and truck ahead. And that can have varying results because you can't think about a color parameter fading on its own in a live color fade. You've got to think about what the result of a color system is, right? And that's what all these tools really, really embody and wrap up, is that we care about the resultant of a color system and maybe less about individual parameters for the most part. We can apply a color path if we want to override a native color fade. And this is in some ways allowing you to not use some discrete timing and discrete delays. In other ways, it can give you some more complex tools that are close to what effects can do, but aren't effects. But all in all, it allows you to change the math and the characteristics of how a color fades. I like to think of more of it as a curve the same way that we use curves for dimmers and other parameters. It doesn't change point A and point B. It adjusts the math of how it goes from point A to point B. So don't think about it as an absolute. Don't think about it as I want to go to this color, then this color, then this color, then this color. Think about it as a series of algorithms that you're adding to adjust the spline, perhaps. A quick sidebar, because I get asked this all the time. If you want to go from point A to point B to point C to point D in a space, that's either a series of cues or an effect, right? What we want you to be able to do with this tool is apply math and then reuse that math even if you're going between two different colors, right? So paths tend to be more fixture specific than they are caring about which color we're going between. So keep that in mind. A quick tour of the color fade path section of the tools. You have a drop-down menu that allows you to select what path you want. You also can access through the command line because you have a path hard key or soft key, and all paths have a number, defaults as well as ones you've stored. Below that, you have the scrubber and preview bar. The graphic is going to preview sort of a quick, what is this fade going to look like as it transitions. But you can click and drag on that as well, and that will give you a quick manual preview live on stage with the fixtures that you've selected. So this is great because you can grab your cyc, and before you commit to that transition, just scrub through it and see, oh, at 60% of this fade is where my trouble is. I want to try and adjust that. Below that, same thing. We've got preview for manual previews, but this is timed. So you have the queue time, or you have the go to queue time that's stored, right? So you can use either of those. We give you 5 seconds or 10 seconds. Or you can do a pause, a play, or a jump to end. So those are just quick little tools that allow you to preview that before you actually store it or commit it to a queue, which is nice. And then below that, based on whatever path you've selected, you'll get different control tools, right? Similarly to the different color spaces, we had different tools in the control bars that related to that color space. We're going to show you tools that relate to the type of work you're doing. And again, this is all abstract. We're not controlling the individual parameters. We're controlling the math that will set the XYZ transition that will then be translated. So for example, in a gel space, we give you in color and out color and brightness. Those flags that are at the front and back of each of those are draggable. So you click on delay and drag it in, you click on time and drag it in, and that allows you to start to set the characteristic of how that fade happens. Do you want the yellow to sit a little bit longer, so you delay the in color? Do you want the out color to finish a little faster? All of that is just stuff that you will play with in the moment when you're setting your fade. The other thing that's nice that isn't a part of the selection, or excuse me, isn't a part of the fade path tool directly, but is really nice to have, is having a color space. So I have the CIE color space here, but we will show you when you have channels selected, if there's a path assigned to those channels, we're going to show you that path in the color space. So this is based on channel selection. So keep that in mind. If you have nothing selected, we're not going to show you anything in the space. So just a quick preview of some of the color paths. One of the options is your hue saturation. And again, because hue is a circular parameter, what this path looks like is sort of like a wander through all the colors because we're fading around the space. So in this particular example, I'm fading just my hue because I'm going from one really saturate color to another really saturate color. If I were to look at this on the circular color space, the HSB space, that would be a round wheel around the outside. My saturation parameter actually hasn't adjusted very much. So again, this is one of the reasons why native control of a fixture and hue saturation isn't really desirable, is because what you really want is a straight line through the color space. So, you know, you get this kind of like very bright rainbowy thing. And you know, if you're doing Mamma Mia, like maybe this is your fade path. Maybe this is what you want to do. If you're doing a sunset or a sunrise where you're going from dark blue night to amber morning, going through green will probably get you yelled at. So HueSat is useful for some applications, but again, as a native way to control stuff, you may not want to use it. Gel is a really great space, and gel mimics if you had two source 4s, one with blue, one with amber, and you just crossfade the two dimmers, right? So we allow you to do that in the same fixture. When they were doing all the research for this, we really wanted to mimic a gel fade. That's really important to most of our users. And you know, the team was like, we've got to measure a bunch of crossfades at different increments, and they actually set up a bunch of tests in Wisconsin where they did like 30 different gel color combinations, and they were fading from A to B and metering every percentage point of the fade. And one of the engineers said, you know, it's just going to be a straight line through the CIE space. And they were like, no, you know, it's nuanced, it's subtle. We got to really do this. And it was a straight line through the CIE color space every single time. So this is a really good tool if you want to mimic two fixtures fading between one another. But what generally happens, because we're filtering out a lot of lights with gel, especially in the saturate side of the spectrum, you get a little dip in the brightness as they both reach that 50% point when they're crossfading. So we give you another tool that allows you to dip that brightness. My basic remedy is, if you don't like how two colors are crossfading between one and the same fixture, set yourself a gel curve, drop the brightness down to 25%, and that fixes a lot of problems. So that's my quick start here solution. As I sort of talked about at the very beginning of this presentation, a lot of these tools can be really nuanced and technical and detailed. If you have a quick macro that applies a gel with a 25% brightness, and that fixes a lot of stuff, that's a fast way to just keep moving through tech without even having to open this display and adjust and fiddle with it. So I like to start there. It's a personal preference. You'll probably find a lot of others that you like as well. There's an additional fade curve called auto dim. The gel curves, depending on the colors that you're going between and the capabilities of the fixture, particularly with less emitters, RGBA, RGB, you can get some stutters and some pops as it transitions. The auto dim path is designed to alleviate some of those, where it keeps the brightness consistent through the fade and allows you to overall adjust the brightness. So if you're getting some weird poppiness, consider using an auto dim instead of a gel. It may get you out of some issues. But again, this is just going to depend case by case basis. And I think what you'll discover is certain fixtures will like certain fade paths better. There's actually a place in Patch where if there's a fade path that is working really, really well for a particular fixture type, you can set the fade path, and it will by default use that path every time. And then you can always override it on the Q level. And really quickly, color space paths like RGB, it's related exactly to the color space that we were talking about. You're not actually adjusting the red, the green, and the blue of the emitters. You're delaying the green in that color space. So this is totally applicable to a CMY space, to a 7-color space, whatever you want it to be. And you'll actually, as you delay those things, you'll see sort of like dog legs that go into that space because it's shifting more magenta and away from green, for example. So use these spaces. If you're crossfading across white, sometimes that white can be really bright in an LED and really undesirable. I'll use this fade path, not because I actually want to adjust the RGB or because my fixtures are even RGB, but I want to move away from the green just on the magenta side of white. So consider that if you're passing through white. Storing a color path. So we store color paths in the destination queue. So if you're going in this example from an amber to a blue, you can see that that's happening because my current crosshairs for my chromaticity are in blue. I'm coming from amber, so this is maybe a sunset. We store it in the destination queue because when you hit go on that queue, we're using that math to calculate that fade. So again, we want you to be able to use a path that works for a fixture, queue to queue to queue, regardless of whether you're going from color A to B or C to D or wherever. To adjust the color path, just grab the channels, select the color path, and then you can make your adjustments. You have the ability to store those as custom paths. Really quickly, when you apply a color path, you get a little red C. So it's just like discrete timing. So you can see that C. And when you store it, that will turn blue, just like discrete timing does. You can also hold About and the Path button, and that's going to show you what path you're using. Similar to holding About and other targets, this gets you information on your live channel display. That's pretty useful. Finally, we manage our color paths in the color path tab. Again, it will allow you to store and add your own. If you have a color path that you started with, like gel, and you make some adjustments, store that as your own custom color path, and then you can always recall that by using the color path number. So your color path area is where you can go in and manage those things. And then just keep in mind that color paths are reference data, right? So if I am using color path 101 and I adjust it, every space I'm using color path 101 is going to be adjusted. That's a good thing. That's powerful if you know that that's what it's doing. It's bad if you don't expect it. But keep in mind that paths are referenced in the same way that palettes, presets, and all sorts of other things are. So before we get to general questions, is there anything in particular about paths?
There are not any color path specific questions.
Okay, great.
They just came in. Here they come. Okay.
Go.
Isaac asks, if color fade path data is stored as a reference data to queues, if I was to look for it in blind, where would I look?
So what you can do is select those channels in blind with a color picker open. We don't right now. It's been on the list for a long time, and again, just hasn't been gotten to. We don't have a way to display that in blind separate from channel selection because your color path can be different for each channel stored in a queue. And with the math abstracted from points, you can't really see what it's doing. So right now, if you go into your color path list, it just shows you the name and the base of it and some attributes. So the way to do it on a channel by channel, queue by queue basis is to go into blind, select your channels, and have a color picker open. And the color picker will show you the blind view of those channels. So that's kind of how you deal with
it. Next question. Can a color path be pushed as absolute data?
You can't make a path absolute. I'm 99% sure. You would just record another color path if you were making adjustments to it.
Okay. Next question. So do you have to store a separate color path if adjusted as standard path and don't want to destroy that?
Yeah, right. It's exactly like your default effects, right? If I make a modification to effect 901 and channels are using effect 901, then that's going to change that. So we do allow you to make adjustments over top of the default. If you don't want to do that or you accidentally did it, copy that default away to a different target number. And if you delete the default in its position, it will just restore it to its defaults. So it's exactly the same way that we deal with effects for defaults.
Next question. How come a color path can be the same between colors A and B and C and D?
Because we're not storing your start color or your stop color. That stuff is stored in the queue, right? So let's say between queues 1 and 2, I'm going between amber and blue. When I hit go to go between those queues, the path is just the math that's being applied as to how that moves between those spaces. If I then in queues 3 and 4 am going between green and yellow, that same math is going to be applied. It doesn't matter that they're different colors, right? So that's why color paths are very different from something like an absolute effect that says go to this color, go to this color, go to this color. It's just like a dimmer curve, right? It is the characteristic of the fade. It isn't the start point or the stop point. I hope that makes sense.
Next question. Are there any other go-to color path settings that you find yourself using often, things that might be helpful to try first or generally?
You know, since auto dim has been enabled or has been a part of the software, I have not had a chance to use it. I haven't worked on a show where I've been dealing with a lot of paths since then. But that would be something that I would add to my repertoire if I were going back into a theater show. You know, there were a lot of times when the gel thing would bump. So if it's a show where I know I'm going to be using a lot of paths, going all the way back to the first section that we covered, I would have that tool available so that I can make custom changes really quickly on the fly. But if it were something that I knew I was only going to be, or I had a couple of paths that I knew worked on a particular fixture type, you know, maybe I've got color force 72s and I know that this particular path deals with those better. I'm going to make that a macro so that I'm not having to take up space with the color picker. So I think there's a balance, you know, trying to anticipate what you're going to run into ahead of tech is always like difficult, right? But any of that you can macrotize, hitting one button will be a lot faster and may get you closer than trying to go in and fiddle if you don't have a lot of time. And it may be that the macro gets you 80% of the way there, you store that, and then you come back on a second pass or a third pass and really refine it. And again, that's why dealing with color paths in the same way that you would deal with color palettes or focus palettes, scene to scene, I'm going to build color paths that are maybe scene related or fixture type related, not necessarily just try and use the same one everywhere, because then it's harder to manage.
A question here just for clarification. Warren asks, so are you saying that when a color path slider is adjusted, that it is an alteration to the original path and needs to be stored as a new path first? Or is the data of the timing / brightness an absolute value / Q level adjustment? Sorry.
Yes, Warren, sorry, you're correct in that you can record those as overrides. So by default, taking a library path, applying it and then adjusting it will result in that only being stored on that queue. It's not going to go through and change that. It's if you record those settings back to that path number. The trouble and why I don't like using absolute is there's really no way to see that stuff without grabbing those channels and looking at the override. And there's no indication that reference is broken, right? That the path that you're using has some overrides on it. So it's a little bit of a precarious area, and I just kind of recommend, if you're going to make those modifications, just make a new path because it's easier to track down later, I think.
Last question on paths. Mark asks, is there anything on the horizon for drawing your own path with a mouse or finger?
No, because we consider that to be more of an effect, right? Again, path is like a curve. If you want to go specifically from a color to a color to a color, that's a queue structure or a playlist or an effect. We allow you to do those things with all of those. Because a path is math-based. It doesn't matter your start and stop color, and that's kind of the power of a path. So they're different tools, and I know that that's really subtle and maybe hard to understand, but you can already do that sort of thing in 3 different applications. So yeah, I hope that makes sense why we're kind of holding that line.
Great. So that's it for color path questions. I think we have a handful of leftover questions. I don't know if we want to stop the record now and do the close up and then finish the question.
Why don't I do this? I'll close up. If people need to get to Hog starts in about 5 minutes. We'll stick around for questions. I'll keep recording so that if you miss them, this will just be tagged on to the end of the recording when it's put up. But thanks for joining. I hope it helped clarify a lot of stuff. You know, I think the whole knowledge is power thing is a really good thing. And, you know, the color system was based on years of research and trying to solve problems. So I think that as you use these color tools, the more you can understand about why we came to the conclusions we did will inform why the tools exist in the way that they do. So in Anne's presentation a couple weeks ago, she said you kind of have to learn the language of the console. It's not going to learn a lot from you. I hope that this presentation helped clarify some of the ways to approach the color system in particular for EOS and why it makes the decisions that it makes. So thanks for joining. Run away if you have to, but otherwise we'll stick around and take questions.
Great. I'm going to go back and get some of the older questions that we had missed.
Yeah.
So Alexander, let's see, is that the one? Where's the question I want? Yes. Alexander asks, when color point is holding, so going back to kind of color point adjustment tools, is it possible to adjust a few colors simultaneously? For example, I need to bring red and amber to 0. Will they hold after my changes? Are there any rules to that?
Yeah, there are some rules. You can min and max out some parameters. So when hold color point is enabled, it's going to lock that chromaticity. And if you try and move a parameter beyond the extents where it would have to break that, it will give you a little red notification that says max limit reached or min limit reached. And so it holds you into that space, which is great. Because they're basically encoders, you can't really control multiple at the same time. You can kind of like click and drag this one over here, click and drag this one over here. One of the things you could try is controlling both the encoders at the same time, right? Because that's going to be physical, or one controller on the encoder and one on the screen. Yeah, I would say that the way that I would kind of do it if I needed to keep red and amber coming down at the same time, for example, is I would just nudge one down. And I'm, you know, you're not doing this in previs because, again, your pre-visualization monitor is going to be RGB, so it's not going to show you this kind of subtlety. RGB monitors don't have Metamer. You're going to be doing this in a space in front of people. So while you may play and learn and see some of these things, until you're sitting in front of a light with 4 or more colors pointed at a complex reflective surface, you're not going to have a lot to play with, right? So I know it's tough for right now, but as soon as you have the ability to sit in a dark room, I like to, you know, toss fabric of different dye lots and things like that onto a table or a mannequin, and something like a RGBL fixture or a 7-color fixture or an RGBA fixture. Those are great ones to play with for Metamer. And it's, your eyes are going to perceive stuff that displays can't duplicate, which is actually one of the reasons why for such a long time I know Tom was hesitant to film his R80 presentation, because it's hard to show those subtleties when you're just dealing with a camera. So what else?
Next question. see, we got a lot of stuff here. Philippe asks, what is the best way to fan colors on multiple fixtures?
So you can fan between colors. Trying to remember, we covered that in our levels 1 through 4, right, Rob? There's the ability with color palettes to fan between them, so that's a really great way to start. And I believe you can do it on the command line as well, though I haven't tried it recently and don't remember. But definitely with color palettes, if you have a blue color palette and an amber color palette, you can say, give me channels 1 through 50, color palette 1 through 2, and it will fan those, and it will put a gradient between them. But we cover that in, I believe, either level 3 or level 4 of our training videos, so I would say go check that stuff out there.
Great. Next question. Let's see. This one was sitting here for a while, but I think it's an interesting point. Osman says, more color system, 8x, more through gel picker match, which I guess means, is it true that the more emitters that we have available to us, the more colors that we're going to be able to get to with our color picker?
That's exactly right. And hi, Osman. Good to see you. Yeah, that's exactly right. The whole reason that the Phos4 and any luster array in new product moving forward will have 8 color is because that deep red significantly expands the gamut in the red. So absolutely, we're going to have more gel matches. Your gel matches will be richer. You know, I like to use R80 as an example. Roscoe Lux 80 is a blue appearing gel, but the dominant wavelength is actually in the red, right? The wavelength with the most spectral output in that gel is all of the deep red into infrared. So R80 is a really warm blue. It looks good on skin. You know, it feeds the blood that's just under skin. It looks really good on warm fabric. It doesn't kill those fabrics quite as much as other colors do, or like a blue LED does. So when you start looking at some of those spectral power distributions of gels, because we're filtering an incandescent source and there's the most of the red, deep red into infrared, that's something that LEDs as a technology has really been missing in a lot of designers' eyes. I know it's something that I really, really miss. That deep red pumps that back in. So not only are we going to have a lot more fidelity in our warm colors, our cool colors and our white colors are all going to look a lot more richer and have a lot more fill to them. So that was really the compelling reason to go to an X8. Is deep red is something that we've been missing since we've started to move away from incandescent, and it's something LEDs haven't been able to do until now. So I think the fixture team and Wendy and her research team have done a great job in finding this new technology in the emitter market that allows us to really not just do an incremental shift. If you haven't seen the deep red in person, when we all get back to normal, I really encourage you to find a way to see it. It's not just another red emitter. It makes red look orange in comparison. It's pretty stunning. So yeah, good question, Osman.
Next question. Andrew asks, I've got color source units, RGBL, and Chauvet Colorado 2's RGBW units with very strong blue indigo emitters. There's no visible difference between dark blue gels and the picker. Any solutions other than eyeballing and re-recording color palettes?
Sorry, I'm just going to try and find it and reread it. Or is it gone already?
Oh,
I see it. Yeah, so yeah, the thing is if the Colorados aren't color calibrated, you are not going to be able to get as close of a color. No, I think the best thing in that case is color palettes. So what you can do, and again, I think I mentioned this in the gel area, we were talking about it, but the gel picker is a really great shortcut, right? So ideally before tech, what you would do is take all of your different color systems in your space and set them to R80 and then go in and adjust each system. And the way that I actually like to do that is I'll build a group with subgroups for each color space. So for example, to build color palettes, I would build a group with all of my color changing fixtures. And then in the first subgroup would be my color source fixtures. In my second group would be my Colorado fixtures. In my third group would be my 7 color fixtures, whatever, right? Because what that allows me to do is grab the group 101, at full enter, at R80, great. And then next, and have those fixtures make their best R80. And then next, and have those fixtures make their best R80. And so on until all of my color systems are making the best R80 to my eyes that they can make, and then store that as a palette, right? So ideally, you have time to do that before tech. Again, the color picker is only going to do the best that it can do with the information that it has and the capability of the fixture. So I know in blue in particular, a lot of manufacturers will call their blue blue when it's actually indigo. Eos doesn't know that, right? If the profile says blue and we don't have color calibration information for it, we're going to assume that it's blue, which maybe is more green than the indigo side of stuff. You're going to get a lot of different disparages in colors. In our own line, we run into that where color source has 2 branches. You have the color source original, which uses a blue emitter, the blue emitter that's in our 7 color system. And then you have the deep blue, which is an indigo emitter. And so the trouble there is if you patch a standard color source fixture and you hang a deep blue fixture, your color math is all off. And we make this stuff, right? So like you've just got to be precise and give Eos a fighting chance to do its best, but it's always going to be limited by what gamut information we have and the accuracy of that fixture. Good question.
Let's see. Question from Ben.
Hi, Ben.
Why will the math be different with 2 variants of the same product using the same modes, i.e. color force 12 and 72 in RGB8 control?
Because the world is a horrible and unfair place. So for those of you that don't know, we use a sister company in the industry called Carillon. They don't face end users, they face other companies. And they do our libraries for us. And so they provide us with a ton of, we could have a staff of 100 people and we'd still never be able to keep up with every new fixture that's coming out on the market every single day. So Carillon does a great job of collecting as much information as they can about a fixture and as much accurate information as they can and packaging it up into a library. And then Eos and other manufacturers, by the way, a lot of other manufacturers using the Carillon library, unpackages that library and interprets it in its own way. Because there are just under 1 billion new fixtures every week, it feels like, sometimes information that was put into a different size of even the same fixture type is inaccurate in one and more accurate in another, or vice versa. We do what we can as we hear about those things to go through and change them. Something for the first time, we copy it out of the library that's in the desk and we put it into your show file. And as you save the show file over and over and over, even if your software updates, which updates the library underneath, we're not replacing the profile in that fixture or in that show file, and that includes all the Gamut data. So if you're using a base show file, or if you're copying from another show file, or importing fixtures from another show file, you're getting all the information that came with those files. So you may want to look at trying to find a point where you can do a fresh start, because that bad data, even if we fix it in our library, is just going to keep trucking through. So those are the things that I would say about that. Good question. Sorry.
No worries, you're fine. Question from Matt Binkowitz.
Hey, Matt.
So as it appears to me, just from trying with a generic RGB fixture, the triangle Kodak seems to be what it assumes as the default color space for uncalibrated fixtures, i.e. I can click anywhere in the Kodak circle. Does this mean it assumes, oh, he got cut off. Any general fixture uses the Kodak, I guess, I think is what his question is.
I believe that is true. I don't have evidence. I actually thought about that, putting this presentation together, and then I forgot to ask our developer what those what those generic spaces are. But it is highly likely that the generic RGB would be that Kodak ProPhoto space. So far as other color systems that we recognize, I don't have that information off the top of my head. But again, at the end of the day, it's going to be a guess anyway, so I could probably give you that information, but I'm not sure that it would matter. I saw a question breeze by, and it's a question that we get pretty regularly. Is there the ability to set in EOS your own gamut, basically, for a fixture? The answer right now is no. What would be really nice, in the long run, is the ability for you to take the spectral power distribution data of every color parameter of every light that you have and input that into the system and have the system respond to that. That does not exist right now, and that's a lot of work and a lot of back-end stuff that may not result in a lot of improvement. So it's kind of on the back burner right now. It's definitely something we've talked about. It's the way to move color precision forward, is us knowing the actual spectral power distribution of every light, not some library model, not some generic model, but a real in-the-field light. It's not there, and it is a lot of work for realistically what will probably be modest improvements. We understand what those steps are. Maybe we'll take them, maybe we won't. But again, I encourage you to consider most of these color picking tools as a start here point, because you're always going to want to go in and actually adjust the color of minimally each color space in your rig, and potentially individual fixtures. These are not substitutes for your eyeballs. These are tools that will hopefully get you places quicker. So hope that helps.
I think this might be a good topic to touch on. Would it be okay to ask you guys to explain the Series 2 luster different reactions to color picking and transitions depending on mode?
Yeah, absolutely. So I had another slide from a previous presentation that I did that I almost included in this, which was more about the fixtures than it was about the console, so I kind of cut it. But it basically states that, like, EOS is doing all of this really clever advanced math and then translating it to communicate DMX levels to a fixture, which is great, right? However, certain modes of certain fixtures, ours fixtures included, have their own math that they're piling on top of that. So luster fixtures, desire fixtures, those fixture lines all have two types of modes. One of them is called direct mode, which is where you're just hot wired to the emitters. We don't do any sort of math to try and help you get to a better color or to help your fixture to fixture color matching be better, which lets the math in EOS shine, right? It's just great. The other modes, such as HSI HSI +7, RGB. What those are doing is they're taking a smaller set of parameters like RGB, and they're using the fixture math to find the chromaticity that RGB went to and shift it, right? Put it into a 7-color system. What that means is the fixture is making choices about things like Metamer. So it's always going to go to the brightest Metamer when it goes to a particular chromaticity using RGB. So you lose a bit of the control that EOS affords you when you put math in the fixture. And this is why this in-between space, a direct mode that is also calibrated for fixture to fixture, has been so hard and has taken the researchers years to put together. Is they had to find a kind of a magical way to allow the fixtures to know how to get to a golden fixture, but also allow you direct controls like Metamer control from a console source. And that's what is really exciting about the new firmware for the Series 2 fixtures, is that they're able to do that, right? So you get the things like Metamer control, you get the ability to adjust stuff, and then the only compensation, the only math that's being done in the fixture is slight adjustments to colors that surround a particular emitter, right? So you're not dragging through the whole color space. You're doing a little bit of compensation in a small area of the color space. So I personally have always preferred direct, because as a programmer, I want control to say that light isn't doing what I want, get the math out of the way, let me just handle it. But certainly from fixture to fixture consistency, calibrated mode has always been better, especially as LEDs in the same generation of fixtures have gotten brighter, and things like that. So that's why those modes exist. And all those modes were really invented back before any of the console color tools existed. I wonder if we would make the same choices if we had all these color tools in EOS done before we came up with those fixtures. But all of the things that we ran into in developing those fixtures were a lot of what informed our color tools in EOS. So I hope that helps explain that and how those kind of came to be. Try the direct mode with the new firmware. I believe Jason can confirm. I believe it's 1.8.1, and it's available for every Series 2 fixture, because those are the fixtures that have the chipset that's able to do it. It's also going to be available in phosphor panel lights. So there you go.
Next question, which is something we haven't totally touched on that I think is valid to bring up. Regarding the earlier question on keeping data updated, is there any better way to maintain color data for a facility other than a base file that would need to be rebuilt as fixture libraries are updated? Or is that the best solution currently?
That's the best solution for now. You can merge in your paths separately. So that's something that if you're dealing with fade stuff, that's important. If you're dealing with profiles, you can update profiles individually in 3.0, so that will help. I would recommend, that isn't undoable, so I'd recommend in some downtime, maybe in a shop, doing a side-by-side. But generally, most fixtures, we're not updating the fixture profile every single build, right? Only when we get new information or we're correcting information. So one of the things that we haven't had a metaphor for is showing you which fixtures in patch contain color calibration data and which don't. What's kind of nice is 3.0, we show you in patch which profiles contain augmented models and which don't. Now that we have that metaphor, maybe we can start in future builds showing you which fixtures do and don't contain color calibration data. So that might inform you a bit better if you were saying, oh, hey, I use these fixtures all the time. I'm just going to pop into the library and see if there's new color calibration data. So that is something that we're looking to improve on. But right now, I think it's going to be kind of just every once in a while checking on the profile and doing a side-by-side. There's really not a way to manage that for a rep plot type of situation or rep inventory. One of the things you may want to do is do files that you keep separated by manufacturer or by other smaller chunks so that they're more easily updated. I don't know if that's worth your time or effort, but it might be a way to compartmentalize that stuff a bit more. So, what else?
Michael asks, if I start with a palette and then tap any tint button to adjust, the data and color of most fixtures makes a huge jump in color. My workaround has been to press Make Absolute before tinting. Is this a bug or by design?
I think that's a bug. Ideally, that tool should be able to just take you wherever you are in the color space and adjust you. So if I would say maybe do some testing in the 3.0 beta if you can, and if it seems like that's still an issue, report it to the forums. There are some gremlins out there because now that you sort of know how abstract the math is, the translation, there's hiccups that we find occasionally. Yeah, report those to the forums so we can assess it and take care of it for you. Are there any other questions or anything we want to cover?
We made a lot, Sam. There was one, and you may have said this already. I've been trying to answer some questions in text. Is this why there's not global color palettes across different fixtures with the same parameters?
That's not why. Global palette.
This is from this is an old question. So.
Oh, good. Well, I see it. Dan, I hope you're still in here. Global palettes are something that's on our list. We have a halfway point, which we use by type palettes, but those don't allow you to set a palette for things with similar parameter groupings, color systems, for example. Again, I think that there's a bit of flaw in that. Not to say that we don't want to do it, but when we do get to global color palettes, that doesn't mean that if you have 4 fixture types that are all RGB, that they're all going to be able to go to the exact same color, right? So again, the start here colors that are in your standard color library are a really good step in that. Even if you had a global color palette, which was for every RGB system, if their gamut doesn't line up, it doesn't matter. They're not all going to go to the same blue or the same amber or whatever. So I just worry, a lot of people think that global color palettes are going to solve fixture type to fixture type matching, and it's not. The more we know about gamuts, that will start to solve that issue. So I think the best thing that can be done as a consumer is to try and get manufacturers to submit their color calibration data to Carillon. That really is what will improve this engine. The engine is there. The engine can adjust to these things if accurate data is provided as part of the fixture profile. I think that will help that sort of fixture to fixture, type to type issue more than something like a global palette will. So thanks for that.
Great. I think, is that all that we want to address?
There was one more that was unanswered that I saw that says, is there the reason why Spectrum data doesn't display for some of the fixtures using a generic gamut? Yeah, so we used to display generic information in the Spectrum view. We don't anymore. I think we suppressed that. I don't know when or why that decision was made, but I think that that's a change. If it is an issue, consider posting it to the forums. Our development team and our marketing management team and our technical management team watch the forums to bring stuff in and do build reports and bug reports. So if you're running into something, check it out. I'd imagine the decision was probably made because it's not particularly accurate, but that doesn't mean it's not always useful. So if we adjusted something or took something that breaks your workflow, just set it up on the forums and we'll have a look at it.
The last thing is there were 2 questions asking about GTTF and how that might help with color use, and if that's something that ETC is working on.
You know, I have not dug deep into the GDTF standard, but if the GDTF standard includes Gamut data, yeah, that's great. I don't think that it does. I don't want to be quoted as the expert on GDTF. I've only gone a little bit deep on it. But basically what we need is we need Gamut information from the fixtures and from the manufacturer. So potentially, but GDTF is only going to be as good as the information that's provided as part of the standard. And right now our Carillon library data has at least the potential to include that for a lot of fixtures. And I'm unsure if that's part of the GDTF standard. If this is something that's important to you, then you need to reach out to the people that are creating GDTF as a standard and suggest that as an addendum. You know, the console is only going to be able to do what it can do with the information that's provided. And I think more and more, everybody wants all this stuff to work together. That means that fixture manufacturers have to provide data to the control system that tells us what their unit is doing and is capable of doing. So I am highly suspicious that GDTF will not improve currently color calibration above the types of profile libraries that we use for Eos right now, which is Carillon. That's an opinion based on the state that I know.
We did it.
We did it. Well, good job. Well, thanks everybody.
We solved color.
Who hung around to the bitter end. If you have further questions, again, don't hesitate to reach out to any of us. My email's up there. Our email formula is not hard. Rob Crane, Jason Perry are also great resources. If you have non-critical information or questions, service@etcconnect.com is managed by our phone support people. They're great and helpful as well. And even in these times, if there's a critical need, our phone support's open. So if you're stuck on a production, give them a yell. So we're always happy to help where we can. Thanks, everybody. I think that's it for today. If you have questions or comments, let me know. We'll post this for future viewing on the web when we get it. And stay safe and have a great day. Thanks, everybody.
Thanks, everyone. Take care.
Thanks, guys.